Hello, everyone. As I am aware, a lot of you love the Shadergraph videos I made. So I'm gonna make another video about some practical usage of Shadergraph in my game, as well as something that is gonna be very useful for you. So in my game, I have a procedural system for enemies, and I wanted to create a shader that would allow me to get like tons and tons of enemy shapes. So that's the shader we're gonna make and discuss today. So my idea was to have procedurally generated enemies, but of course they have to look different and be identifiable enough. So the shader that is giving me this shape and this shape and this shape, it's the same shader. So that's what we're gonna do today. I'm gonna explain how I made the shader and what it can do. So let's go into the shader and start discussing it as well as making it. I'll try to make certain aspects of the shader again in order to explain them. Okay, so the very first thing. So I start with a sphere. Okay, so I'm using a mesh that is a sphere. So I did not use the original Unity sphere because it wasn't detailed enough. So I used my own sphere that had a little bit more vertices on it and better UV. And by better UV, I mean, let me quickly show you. So if you remember from my last videos, you can observe the UVs of things by plugging the UV node into the base color. Let me remove the alpha as well. So that's the UV of how this is. Now, if I use the another sphere, so I created another sphere using uh, Pro Builder. Initially, I thought it was going to work, but it had some serious issues with its UVs. Let me show you. I subdivided it, and it kind of didn't give me what I was looking for. So I think it was this one, this one, this one. Nope, I don't think it's even showing me the changes. Oh, it's not. It's not going to show me the changes like this. I'm going to have to go into the prefab. Okay, so if I change the sphere here, okay, so this one's not the one I was talking about, and there was this. Okay, this one. So if you notice, its UVs were not what we need. So that's why it did not give us this smooth result. The original sphere that comes with Unity has workable UVs, but it's too low poly. So I had to use another sphere from Blender. Okay, so now that I kind of explained that thing, let me go to the shader graph. Where is it? Okay, so let's unplug this. Let me put in my base color and alpha. So it looks like how it's supposed to in my game. And now let's discuss this. Okay, so first of all, we have this sphere. And in fact, let's not use alpha. It's easier to see. In fact, let me go back to the UV since we are first, we want to observe what happens. Okay, so this node gives us the each vertex's position, okay, in object space. Now, you have to imagine this shader running on each vertex. So every time this position is going to be different when this whole thing goes through this process. So I split the positions into X, Y, Z. So, and then I combine them again. This combination is not technically needed because initially I wasn't considering one of the directions. So I had this disconnected. That's why I have this combined node. So technically it's not needed anymore because then I integrated all the directions into my system. Initially, I was thinking since my game is 2D, I only need to extract in left, right, up, down directions, but it wasn't looking good because it wasn't considering this vertex. So if you look from above, you wouldn't get this curve. So that was the issue. So you wouldn't get this curve because it wouldn't be considering any vertex that was, a bit way too high. So I included the Y position as well. And let me actually show you the problem with this. So if you can see, the bulge kind of assumes I have to touch all the vertices, no matter their Z position. So it kind of becomes like this. But if I introduce the Y position as well, then the Y position's inclination towards this direction is also considered, and you kind of get this. So what is actually happening here is I take the X, Y, Z directions and then I normalize them. What this normalize does is we're not interested in how far away and the actual magnitude of the vector from the center point to that position. So if I open up quickly, yeah, okay. So if I open up Calligraph to draw something, or maybe paint. So if imagine this is a sphere, right? So this is the position, and that position is kind of represented in a vector like this, right? So I normalize that vector to make it inside a unit circle. So because right now I'm not interested in how far away that vertex is from the center, I'm only interested in which direction from the center that this vertex is, right? So instead of using this whole vector with the magnitude included, I am normalizing it so the magnitude is always 1. The reason for this is if I include the magnitude, then the vertices that are far away from the center are going to get more push towards the outside. I wanted to control the magnitude later in the shader. So then after we normalize it, we take dot product of that vector and compare it with a lot of directions. So I have 8 directions, but I didn't need to make them make them parameters, but I made them in order to test them out from outside. So this is forward right, 0.707 minus all of these values are basically normalized values. So -1, the right. So it's a 2D game. So I imagined it like this is the forward, this is right, this is left, this is back. So this is forward left, this is forward right. So I hard coded some vectors. So this is representing right. So -1 in y. This is representing back right. This is representing back. So -1 in x. So all of these vectors are basically just hard coded. So then I compare them with this the normalized vector that we created. So once we have this vector, this normalized vector, so this normalized vector, what I'm actually doing now is asking, this is my right vector and this is my back vector. This is my forward left and forward right. So I'm comparing them each vertex, right? So imagine this vertex is being discussed, right? In that run, the code is running for this vertex. So compare that vertex's position with this, and you're gonna get a dot product. A dot product is basically you get 1 if it's parallel, you get 0 if it's perpendicular, and you get -1 if it's opposites, right? So this vector is probably going to, this vertex is probably going to give me 0.5, right? Then this vertex is also going to get compared by all of them. So when it gets compared by this, it's probably going to give me a negative value. Then it's going to get compared by this, and it's going to give me near 1 because it's kind of forward left. So it gets compared with all of these vectors one by one, and all of these vectors. So when you compare them, so maybe I get 0.1 here, 1 here, -1 here, 0.5 here. So it's basically telling me which directions it aligns the most with. Okay. So the next thing I do is I smooth step it so that I can basically control how much like harshly I want to judge the direction of the uh, vertex. So for example, if it's if I do a smooth step, so basically I get this whole range 1 to 0. If the smooth step is set to edge 1 is 0, edge 1. But if I increase the edge 1 to 0.2, what I'm saying is if the vertex is farther away then just consider it 0. Just consider that this vector doesn't give a about this direction at all. So in essence, what this does is if, and I have named that parameter as thickness of arms, okay? And I am doing a 1 minus because rather than doing a thinness of arms, it kind of made more sense to have thickness of arms. Okay, so if thickness of arms is 0.1, it goes into edge 1. And what I'm saying is any direction, sorry, if that vertex is like 0.1 in this direction, just consider it 0. So what that does is, let's take this course sphere and let's go into this material. Now, what we're doing is we're saying, now, if the thickness of arms is higher, we're letting more of these vertices join the growth in this direction. So any vertex, so this vertex got to join as well. And this bulge, so we were comparing against this direction and this direction, but this bulge kind of ended up becoming bigger than both of them because it got boost from this direction as well as this direction as well. But if I reduce the thickness, now these vertices are being told, nope, you don't qualify for this direction as well, and you don't qualify for this direction as well. So, that smooth step is pushing their value to 0. So they cannot participate in the push I wanted in this direction. So that's why I did the thickness of arms thing and the smooth node. Okay, now this multiply node is another thing. So what it's doing is now creating that dot product back into that kind of that direction. So imagine once we have done all the comparisons, we have ended up with, let's say for this vector, we have ended up with a value of 0.1. So now we're saying push this vector's position by 0.1. But on the other hand, this vector gets multiplied by 1, so its vector stays the same size. But this position's vector gets reduced. So this is like another way of saying the dot product's result is actually a vector in this direction. So when it came out from here, it had become a single value. It wasn't a vector 3 anymore. When it came out from the dot product, it was 0.1 or 1 or 0.5. And now I multiplied it by that same direction in order to say push or pull that vector in by whatever amount that dot product is saying. So if it's 0.5, that direction gets cut in half. If it's 1, that direction has full impact for the position of this vector. So then I move on to the next one. And this is just multiplication with uh, my intensity controller. So basically, it's just me now actually adding some value to it. So once I have gotten this vector cut half, now I am saying right vector is 1, and now I'm multiplying it with some number in order to create a bulge here. So this vector is now going to go all the way by getting multiplied by plus 5. This is going to get multiplied by plus 5 as well, but of course its value is going to be less, so it's going to end up here. Then the next one is going to end up here. So, so this curve is we are getting from dot product, and this multiplier is from my variable in this vector 4. So I used a vector 4 because I had 8 directions rather than creating tons of variables. I created 2 vector 4s. So forward, forward, right, right, right. Okay, so if we see here, so that's how I'm controlling the procedural shape of the. So if I say forward 0.5, so this is the multiplier, and I can control the push in this direction. And then that push is getting multiplied by the dot products of those vertices. So that's why some of them are getting less effect, or the easiest way would be to say that they're getting the effect of this direction's push proportional to how much they are in that direction from the center. So none of these other vertices are even bothering about this forward direction due to how we did that. But if we do the back thing, no, no, this is forward left. Okay. Now if we do the back thing, now these vertices are only these vertices are interested in that. And if the thickness of arm is basically tells us how many vertices are actually interested in this direction. So see, more vertices joined in. So that's the trick with the thickness of arms thing. And that's why I did the smooth step over there. Now, let's get back to the shader and let's see what we do next. So this multiplier is giving me a way to push certain directions more than others. So through these vector fours. Now, then after that, we just start adding them together. That's it. So this direction's effect gets added with all the others. So add these two, then these two. Basically, I merge all of them into a single vector. The reason for that is for any vector, so for this vector, its impact is already stored in, sorry, let's study this vector. So its impact is already stored in this vector. Everything else has probably given it zero anyways. So all of those vectors mean nothing to it. So adding all of these things together is still going to get me the vector that corresponds with that push. So that's why I add all of them together. So this is my way of saying whatever vertex is being discussed right now, get the vector that basically represents its direction the best. And then after having multiplied it by, I end up with a vector that basically uh, is as strong as the force I put into it, and also in the direction that makes the most sense for that vertex to move, because by doing the smooth step thing, I eliminated all the other directions that I did not want that to, you know, uh, to part for that vertex to participate in. Once I've added that position, I go back and add that position into the original position of that. Okay, so this is me doing the Z direction, so up and down thing. So this is me doing the up and down, which I later decided to do. That's why so it's the this direction, the blue arrow. So I thought maybe it would look cool, but for a 2D game, it was, since it's an unlit shader uh, for my art style, it wasn't making a lot of sense. So I'd probably uh, is keeping it at -1, and I have no multiplier for it in the exposed multiplier for it. So it's not getting this treatment. So it's not going to push anything up or down. So if you ignore these nodes, all of them, like 1, 2, 3, all of these nodes are basically the y direction nodes. Basically, they're these, right? These four for the y direction. Ignore them. So imagine this line is not passing through here. It's just going here. So, and what was this? This was the original position normalized. So I add this new vector we created to the original position normalized, and then we add the original position. So why are we doing this? Why are we doing the normalized thing? Oh no, sorry. We don't need to add this at all. We can just take it from here. We can just take this node from here and add it here. This is the Y position stuff. Okay, let me actually ignore that so that it doesn't confuse you. Let me do this. Okay, this is just being ignored. We don't need this. So, or take the original position and add that vertex to it. And now what is this doing? So if you know your vertex math, if we take a vector, so this was the original vector for this vertex, and we have now gotten a vertex, uh, like this this created vector, which is also parallel to it. So when we are adding it, we're just pushing this vertex in a certain direction. So this vector is also getting a vector, but it's a little less. So it's get pushed all the way up to here. This one gets to here, and this. So that's how you get the bulge and this bulge, right? So we add the new vector, which is representing our push to the original position. And that's what is actually moving the vertex, right? Of course, if this vector said that it was at 2, 3, right? We add this vector, which was like 3, comma 0. By adding it, we ended up at 5, 3. So it got pushed forward, and the new position was 5, right? So this would actually be 5. The vector in memory would actually be 3, 0. So when we press 3, 0, we'll end up on this position. Now, the next step is we are doing the addition again here because it was all the Y stuff. So since we have gotten here, we actually don't need this, but let's use the Y as well because I just got an idea. Y might actually be able to do something interesting. Okay, let me introduce Y back again. I hope you understand how it's working. So basically after the introduction of Y, this is the final addition, not this. So this is the final addition where we actually push and we add it to the vertex position and you end up with what I had previously. Now, I needed alpha again, but let's not use alpha and let's play with it first. Now I've got a shader which I can attach on something and I can actually create any number of interesting shapes and I intend to use them for my enemies, right? So let's create a material called enemy procedural shape. Okay, so let's quickly create a temporary 3D object. Let's make a sphere and let's put this material on it. And let's update the material to use our shader, which was Shadergraph for sphere. Now, and let's give it the better mesh as well. This one. Now, now we can play with it. Now, my approach is going to be I'm going to create a variation in these numbers through script in order to generate interesting shapes for my enemy. So, and in that procedural system is going to account for symmetry as well. So if it gives forward right, let's suppose 0.2, and forward left would also be 0.2 in order to get symmetrical shapes. But at the same time, it might decide to give 0. minus 0.1 to forward. And so the procedural system will take a seed and give me these numbers, but it will still consider symmetry. So let's say back left would be 0.6, and let's say back right would also be 0.6. So this is, imagine the procedural system working, and then we do minus 0.1 here, and then we change the thickness of arms, and we have got an enemy that is a unique shape through a procedural system. So we can do right and left, or maybe push in. If I had shadows, this might actually look even more interesting because this is a shape that has shadows in it as well, but I am using unlit shaders. So if we look at it from the side, so it has an interesting shape from all sides, and I can actually add some holes in it. So if I had a, of course, lit shader, I might actually be able to create some interesting. So I pull in the forward and I can actually create holes in it. And if I do a double-sided shader, I might actually be able to invert it in certain locations in order to give it a different kind of body. So I hope you like this system. And there you go. We got kind of a fish type thing going on here. And the reason I wanted the upward bulge because it can also kind of give us an interesting shape if I want to use it. So, but my game is 2D and the upward bulge isn't very interesting for my use case. And also, you can have way more than 8 directions. You can have some weird directions as well. So that's why I did this. I wanted to like imagine if I make forward something else, not just forward, like this. So by playing these variables, you were getting some interesting results as well. And if I play with Y, I can actually make it kind of turn its head left and right as well, which can I can do this like through code procedurally or through animation inside the shader, and I can actually end up with a very living, breathing kind of feeling creature. See, it's turning its head up and down. I can let me put it back to 0 and 1, and let's say I can do the right wing. Where's the right wing? So if I move the right wing in X and Y, I can actually do this as well. So the sky is the limit for procedural shapes I can get. And I wanted organic shapes, so this is the approach I took. And then so be all of these numbers, when my procedural system is gonna play with them, it can realistically get a lot of options. So see, check it out. Just playing with these numbers is giving me so many shapes, and it's up to me to use them smartly. Where's my right wing? And then after this point, of course, the game is about uh, writing the procedural system. I am not sure whether guys want to see that or not. If you do, I will make another video. So please comment if you want me to make that video as well, where I write script to play with these procedural values, and I'll add an inspector button here in my script to keep pressing it and seeing all the interesting shapes that it comes up with in order to test how workable these are. And thank you so much for watching. And I know a lot of people unsubscribed because I started sharing some videos about my upcoming game. Actually, this is my upcoming game. It's available on Steam, but my intent wasn't to spam you guys or to promote my game on this learning channel. The idea was that I wasn't, uh, sure where to put them. And my own account was the easiest to access at the time, and I wanted to share links with the Steam page and stuff. I made another company YouTube channel for my studio, but it's not gaining any traction yet. So that was the reason. And I apologize if you guys thought that I wasn't gonna share any more learning videos. Anyways, take care, everyone, and please subscribe. 95% of you guys are not subscribed. So please do. Okay, take care, everyone.